buttons with class name equals bgblue 500, rendered green on some pages and blue on others, no errors, no warnings. The culprit: a missing tailwind-merge in your CN utility. Let's break down advanced Shadcn UI tricks, how it works, and the exact mistake behind that failure. CN is a tiny utility that combines clsx for conditional class joining and tailwind-merge for intelligent tailwind class deduplication. It ensures that when you pass conflicting classes like px4 and px6, the last one wins, preventing unpredictable style overrides. The CN function lives in lib/utils, TS. It first joins classes with clsx, then passes the result through TW-merge, which deduplicates conflicting tailwind utilities. This makes component extension predictable. Here's the actual implementation. It takes any number of class values, joins them with clsx, and then merges with tailwind-merge. Without tailwind-merge, conflicting classes would depend on CSS specificity order. Shadcn/UI's theming is entirely CSS variable-based. Every color, border radius, and spacing is defined in globals, CSS. Change a variable and every component updates instantly. Here's the standard Shadcn/UI theme setup. Variables are defined in HSL format, which enables opacity modifiers like bgprimary/90. The dark class overrides the same variables for dark mode. The asChild prop lets you pass component behavior to any child element. Instead of a wrapper button, the link receives the tooltip behavior directly, eliminating invalid HTML and extra DOM nodes. Here, tooltip trigger uses asChild to pass its behavior to the nextjs link. The link becomes the trigger without any wrapper, keeping the DOM clean and valid. Class variance authority lets you define variant systems with type safety. Compound variants handle specific combinations, and variant props auto-generates TypeScript types from your definition. Here's a badge component using CVA. The variant and size keys map to class strings. Compound variants can handle specific combinations like destructive plus large. The variant props type is auto-derived. Custom hooks wrap Shadcn UI primitives with app-specific behavior. The hook returns state and callbacks, while the component renders the UI. This separation lets you swap the UI layer without changing the logic. This useConfirm hook returns a promise-based confirm function and a confirm dialog component. The hook manages state, the component renders the dialog. Usage is simple: const confirm confirm dialog equals useConfirm, const OK equals await confirm delete. Instead of generic skeletons, build per feature skeletons that exactly match your content layout. This eliminates cumulative layout shift, providing a smooth transition from skeleton to real content. This skeleton matches the dashboard metrics layout exactly. Same grid, same card structure, same dimensions. When real content loads, there's zero layout shift. Dark mode is handled by an inline script in the head that reads local storage and applies the dark class before React hydrates. No React state, no re-renders, no flash. This script must be inline in the head, executing before the first paint. It checks local storage and system preference, then toggles the dark class. The toggle hook simply flips the class and updates local storage. Combine TanStack Table for logic and Shadcn/UI table for rendering. TanStack manages sorting, filtering, and pagination state, while Shadcn/UI provides the visual structure. This data table component wires TanStack table state to Shadcn/UI table components. It handles sorting, filtering, and pagination with minimal boilerplate. Instead of modifying Shadcn/UI source directly, create wrapper components that extend the original. This keeps the original untouched for easy diffing when Shadcn/UI updates. This extended button adds loading state, icon slots, and shortcut hints. The original Shadcn button is re-exported for simple use cases. When Shadcn/UI updates, you diff against the original, not this wrapper. Build a design token system with semantic tokens that reference Shadcn/UI's primitive tokens. This two-layer approach lets you change themes or rebrand without touching component code. Here, semantic tokens like color action primary reference the primitive primary. Theme changes update the primitive, rebranding updates the semantic token. Components use only semantic tokens. This is the same issue we highlighted at the start. Here's exactly why that happened. The team used cn-px4, className with className equals px6. Tailwind-merge keeps the last conflicting class, which is px4. So the consumer's px6 was silently ignored. The cn utility was defined as clsx. Args without tailwind-merge, so CSS specificity order determined which class won, and that varied by import chain. The fix is simple. Always put consumer-provided classes as the first argument to cn. Now cn className, px4, with className equals px6 yields px6, and the button widens as expected. This is the exact mistake from the incident. When you pass default classes first and consumer classes last, tailwind-merge keeps the default because it's the last conflicting class. Always put consumer overrides first. In tailwind-merge v2, the default behavior changed. Conflicting classes now keep the first asterisk occurrence instead of the last. This breaks the assumption in the article that cn, px4, px6 yields px6. To preserve the last wins behavior, pass conflict resolution. Last, in the TW-merge config or pin to v1. Always check your tailwind-merge version when debugging style overrides. To ensure predictable last wins behavior across tailwind-merge versions, configure TW-merge explicitly. This snippet shows a version-safe CN that always keeps the last conflicting class, regardless of the library's default. Tailwind-merge adds ~40 ms to initial bundle parse time, minified ~6 kb gzipped. For most apps this is negligible, but if you're optimizing for core web vitals on slow networks, consider lazy loading the CN utility or using a lighter alternative like TW-merge, a smaller fork. The trade-off is safety versus speed. Silent style bugs are harder to debug than a few milliseconds of parse time. To debug style conflicts, first check the argument order in CN, then verify tailwind-merge is installed and working by logging the output of CN with conflicting classes. If both classes appear, tailwind-merge is missing. Let's run through some common interview questions. What problem does CN solve? Resolves conflicting tailwind classes deterministically. How does tailwind-merge handle conflicts? Keeps the last conflicting class in argument order. What's the difference between clsx and tailwind-merge? clsx joins classes conditionally, tailwind-merge deduplicates conflicting ones. And a few frequently asked questions. Can I use CN without tailwind-merge? Yes, but you lose conflict resolution. Does tailwind-merge affect performance? ON with negligible overhead for typical usage. Can I use CN with custom CSS classes? Yes, tailwind-merge only processes tailwind classes, custom classes pass through. Let's recap the key takeaways. CN equals clsx plus tailwind-merge. Consumer classes must be first in CN. CSS Variables centralize theming. Use asChild for slot composition. Ready to go deeper? Up next, Introduction to JavaScript, then variables in JavaScript, then data types in JavaScript, and operators in JavaScript. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.